The engine block sat on a wooden workbench in the Mitsubishi Heavy Industries testing facility in Nagoya, stripped down to its essential components. It was March of 1945, and Sergeant First Class Takeshi Yamamoto had spent 17 years as a master mechanic for the Imperial Japanese Army. He had rebuilt hundreds of engines, Type 95 reconnaissance cars, Type 97 trucks, even the notoriously temperamental power plants of the Chiha medium tank. He knew engines the way a surgeon knows anatomy. But this engine was different. It had arrived 3 weeks earlier, pulled from a captured American vehicle that Japanese forces had seized during a supply raid on a forward American position in the Philippines. The vehicle itself was unremarkable, a small, open-topped, four-wheeled machine that the Americans called a jeep. What made this particular engine extraordinary was the logbook that had been found in the vehicle's glove box, still legible despite water damage. 10,000 miles. The engine had run for 10,000 miles without a major overhaul. Yamamoto had read the figure 3 times, convinced the translation was wrong. Then he had his assistant verify it. Then he had requested a second translator. The number remained the same, 10,000 miles. In his entire career, he had never seen a Japanese military engine last beyond 3,000 miles without requiring significant mechanical intervention. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The implications of that logbook would haunt Yamamoto for the rest of his life, because what he discovered when he disassembled that engine would force him to confront an uncomfortable truth, one that the Imperial Japanese military had spent years denying, and one that would ultimately explain why Japan was losing the war. This is the story of how a single American engine revealed the fundamental disparity that no amount of warrior spirit could overcome. The gap between Japanese and American industrial capability. To understand why Yamamoto's discovery was so significant, we must first understand the world he inhabited, a world built on carefully constructed beliefs about Japanese superiority and American weakness. By 1945, Japanese soldiers and civilians alike had been immersed for over a decade in a comprehensive narrative about the United States. American society, they were told, was soft, decadent, and materialistic. Americans were individualists who lacked the collective discipline necessary for prolonged warfare. They were, in the words of one widely circulated propaganda piece, a mongrel nation of shopkeepers who would crumble when faced with the superior fighting spirit of the Yamato race. This narrative extended specifically to American manufacturing. Japanese propaganda portrayed American industry as focused on luxury goods and consumer conveniences, automobiles with chrome trim and electric refrigerators, rather than the serious business of war production. The quality of American goods, it was implied, reflected this frivolity. American products were mass-produced, standardized, and therefore inferior to the careful craftsmanship of Japanese manufacturing. There was a kernel of truth to this characterization, but it was a truth that concealed a far more complex reality. Japanese manufacturing in the 1930s and early 1940s did indeed emphasize skilled craftsmanship. A Japanese engine was often a work of individual artistry, with components hand-fitted by experienced machinists who had trained for years in their specialization. Each engine was, in a sense, unique, built to exacting standards, but dependent on the skill of individual workers to achieve those standards. This approach had significant advantages. Japanese engines could achieve remarkable performance specifications when everything worked correctly. The Nakajima Sake engine that powered the legendary Zero fighter, for example, delivered exceptional power-to-weight ratios that American engineers initially struggled to match. But this approach also had profound limitations that would become increasingly apparent as the war progressed. The first limitation was time. Hand-fitting components required skilled workers operating at a pace that could not be rushed without sacrificing quality. A Japanese aircraft engine might take 3 times as long to manufacture as an American equivalent. The second limitation was consistency. When each engine depended on individual craftsmanship, quality varied. Two engines coming off the same production line might perform quite differently depending on which workers had assembled them. This made maintenance and parts replacement enormously complicated, as components from one engine might not fit properly in another. The third limitation was scale. Japan simply did not have enough skilled machinists to produce engines in the quantities that modern warfare demanded. By 1943, Japan was producing approximately 7,000 aircraft engines per year. The United States, in the same period, was producing over 100,000. This disparity was not an accident of resources or population. It reflected fundamentally different philosophies of manufacturing philosophies that had been evolving in the United States for decades before the war began. The roots of American mass production stretched back to the early 19th century, when the United States government had begun requiring interchangeable parts for military firearms. This requirement that any component from one musket should fit perfectly in any other musket of the same model had forced American manufacturers to develop precision machine tools and standardized measurements. By the early 20th century, this approach had been refined into what became known as the American system of manufacturing. Henry Ford's assembly lines were the most famous expression of this philosophy, but the principles extended throughout American industry. The goal was to remove individual skill from the manufacturing process as much as possible, not because American workers were unskilled, but because skill-dependent processes could not be scaled efficiently. Instead of training workers for years to hand-fit components, American manufacturers invested in precision machinery that could produce identical parts by the thousands. Instead of relying on experienced craftsmen to judge quality by eye and touch, they implemented systematic inspection processes with precise measuring instruments. Instead of treating each product as a unique creation, they standardized designs so that any part could be replaced with any other part of the same specification. This philosophy had been applied with particular rigor to the American automotive industry, and it was the automotive industry that would produce the vehicle sitting disassembled on Yamamoto's workbench. The Jeep, officially designated the truck, quarter-ton, 4x4, was the product of an emergency design competition held in the summer of 1940. The United States Army had recognized that it needed a light reconnaissance vehicle to replace horses and motorcycles, and it needed this vehicle immediately. The Army issued specifications on July 11, 1940, and demanded working prototypes within 49 days. 3 companies submitted designs: American Bantam, Willys Overland, and Ford. American Bantam delivered first, creating the basic layout that all subsequent Jeeps would follow. But Bantam was a small company with limited production capacity. When the Army decided to begin mass production, it turned to Willys and Ford and required both companies to produce vehicles that were completely interchangeable with each other. This requirement was extraordinary. 2 different companies, with different factories, different workers, and different management, would produce vehicles so standardized that any part from a Willys Jeep would fit perfectly in a Ford Jeep, and vice versa. This level of standardization would have been essentially impossible under the Japanese manufacturing philosophy. The engine that resulted from this process was the Willys Go Devil, a 60-horsepower, 4-cylinder L-head engine that represented the apotheosis of American mass production engineering. It was not a sophisticated engine. It used simple, proven technologies rather than cutting-edge innovations. It had been designed specifically to be manufactured quickly, cheaply, and consistently by workers with minimal training, using machinery that was widely available. And it was this engine, unpretentious, mass-produced, standardized, that Sergeant Yamamoto was now examining with growing disbelief. The first thing he noticed was the machining. Every surface that should be smooth was smooth. Every surface that should be rough, for oil retention, was uniformly rough. The cylinder bores were not merely round, they were identically round, each one matching the others to within tolerances that Yamamoto could barely measure with the instruments available to him. This was not the result of hand-fitting by skilled craftsmen. This was the result of precision machinery operating at a level of consistency that Japanese industry had not achieved. Yamamoto understood this immediately, because he could see the tool marks. In a hand-fitted engine, tool marks varied, they reflected the individual movements of individual workers. In this American engine, the tool marks were identical from cylinder to cylinder, component to component. But it was when he examined the bearing surfaces that Yamamoto felt the first chill of genuine alarm. In any internal combustion engine, the bearings are critical components. They support the crankshaft and connecting rods, allowing them to rotate at high speed while minimizing friction. Bearing surfaces must be machined to extraordinary precision, smooth enough to prevent wear, but not so smooth that oil cannot adhere to them. They must maintain this precision under extreme heat and pressure over thousands of operating hours. Japanese engine bearings in 1945 were made from materials that required careful manufacturing and frequent replacement. American sanctions on exports of critical materials to Japan, imposed in the years before Pearl Harbor, had forced Japanese industry to use substitute alloys that wore quickly under the stresses of combat operation. A Japanese engine might need new bearings every 500 to 1,000 miles of operation. The bearings in the Go Devil engine were different. Yamamoto had seen American bearing materials before copper-lead alloys with properties superior to Japanese substitutes, but these particular bearings showed something that went beyond materials. They showed barely any wear. 10,000 miles of operation, and the bearings looked almost new. Yamamoto removed one bearing insert and examined it under magnification. The surface was still smooth, still true. He measured it against the original specifications that had been captured along with the engine. The bearing had worn down by perhaps 0.02 of an inch. 0.02. In 10,000 miles. He called his superior officer. Major Hiroshi Endo arrived at the testing facility that afternoon. Endo was not a mechanic, he was an administrative officer responsible for coordinating maintenance reports from field units, but he had technical education and understood immediately why Yamamoto had summoned him. They spent the remainder of the day going through the disassembled engine piece by piece. Yamamoto pointed out feature after feature that demonstrated the same pattern: precision manufacturing, superior materials, and design choices that prioritized reliability and ease of pros. Maintenance over raw performance. The piston rings, for example. In a Japanese engine, piston rings were often made from cast iron and required careful hand-fitting to achieve proper tension against the cylinder walls. The American rings were made from steel with a chromium facing harder, more wear-resistant, and manufactured to such precise specifications that any ring would fit properly in any cylinder. If a ring wore out, a field mechanic could replace it with a spare from any other Jeep engine without adjustment. The valves told a similar story. Japanese engine valves frequently warped under high-temperature operation, requiring skilled mechanics to regrind them to proper specifications, a process that took hours and demanded experience. The American valves were made from silicon chromium steel, a material that maintained its shape under extreme heat. Yamamoto could find no evidence that these valves had ever required adjustment. Even the gaskets, simple sealing components, that most mechanics considered disposable, demonstrated the gap. Japanese gaskets were often made from asbestos composite that deteriorated quickly in the presence of oil and fuel. The American gaskets were made from superior materials that maintained their sealing properties over long service intervals. Every component that Yamamoto examined told the same story. Not better design, not more sophisticated engineering, simply better manufacturing, more precise, more consistent, using superior materials in every application. And the cumulative effect of all these small superiorities was an engine that could run for 10,000 miles without requiring the constant attention that Japanese engines demanded. Yamamoto had spent 17 years as a military mechanic. He had taken pride in his ability to keep Japanese vehicles running under difficult field conditions, coaxing a few hundred more miles from worn bearings, improvising repairs when proper parts were unavailable, applying the skills he had learned through years of apprenticeship. He had believed, as he had been taught to believe, that this skill and dedication were Japan's advantages, that Japanese spirit would compensate for any material deficiencies. Now, examining this mass-produced American engine, he understood that he had been wrong. It was not that American mechanics were more skilled than Japanese mechanics. The opposite was probably true. The Jeep was specifically designed so that mechanics with minimal training could maintain it using standardized procedures and interchangeable parts. The Americans did not need master craftsmen. They had built a system that did not require them, and this system could produce engines by the hundreds of thousands. Yamamoto made his report to Major Endo that evening. He was thorough and technical, documenting each component and its implications. But when he had finished his documentation, he added a final assessment that was not technical at all. "Sir," he said, "if the Americans can build engines like this and build them in the quantities I believe they are building, then we cannot win this war through superior fighting spirit. We are not fighting men. We are fighting factories." Endo was silent for a long moment. Then he asked how widely Yamamoto had shared his findings. Yamamoto had shared them with no one outside the testing facility. "This was fortunate," Endo said. "The assessment was accurate, but it was not the kind of accuracy that could be shared. Reports reaching Tokyo must focus on technical analysis, not strategic conclusions. Strategic conclusions were for officers far above their rank." Yamamoto understood. He rewrote his report, removing everything but the technical specifications. The report travelled up through channels and vanished into the military bureaucracy. No action was taken. But the knowledge stayed with Yamamoto, and over the following weeks, it changed how he saw everything around him. He began to notice how much of his time was spent compensating for manufacturing defects, adjusting components that should have been identical but were not, improvising replacements when standard parts did not fit properly. He noticed how many skilled workers were required to maintain Japanese vehicles, and how difficult it was to train new workers to the necessary standard, as experienced mechanics were killed or transferred to combat units. He began to understand why Japanese supply lines were failing. It was not just that American submarines were sinking transport ships, though they were, with devastating effectiveness. It was that Japanese vehicles required so much maintenance, demanded so many unique components, that the logistics system could not keep pace. A Japanese truck division might need 3 or 4 times as many spare parts as an equivalent American unit, because Japanese parts were not interchangeable and Japanese components wore out faster. And he began to understand why Japanese forces were losing ground across the Pacific, despite fighting with courage and determination that American commanders themselves acknowledged. The Americans were not winning because they were braver or more skilled. They were winning because they had built systems, manufacturing systems, logistics systems, maintenance systems that multiplied the effectiveness of every soldier, every vehicle, every weapon. The Go Devil engine sitting on his workbench was not just an engine. It was a representative artifact of an entire industrial civilization that Japan had fundamentally underestimated. The war that Yamamoto now saw with new eyes had begun, in a sense, with a miscalculation about exactly this kind of industrial capacity. When Japanese military planners had contemplated war with the United States in 1940 and 41, they had not been blind to America's economic power. They knew that the United States possessed greater natural resources, a larger population, and more manufacturing infrastructure than Japan. These facts were not secrets. They were openly published in statistical yearbooks that Japanese planners studied carefully. But knowing a fact and understanding its implications are different things. Japanese strategic thinking in the years before Pearl Harbor had developed an elaborate framework for neutralizing American industrial advantages, a framework built on assumptions about American psychology and the nature of modern warfare. The first assumption was time. Japanese planners believed that modern wars were decided quickly. The German blitzkrieg across France in 1940 had conquered a major European power in 6 weeks. The Japanese attack on Malaya and Singapore would take even less time. A rapid series of overwhelming victories, the planners believed, would present the United States with a fait accompli, a new Pacific reality that would be too costly to reverse. The second assumption was willpower. Even if the United States possessed the industrial capacity to fight a prolonged war, would Americans have the stomach for it? Japanese propaganda portrayed Americans as comfort-loving and individualistic, unwilling to sacrifice personal prosperity for national objectives. A few costly defeats, the theory went, would sap American morale and create pressure for a negotiated settlement. The third assumption was the most critical, that industrial capacity took time to mobilize. American factories in 1941 were producing automobiles and refrigerators, not tanks and aircraft. Converting this capacity to military production would require years during which Japan would consolidate its conquests and build defensive perimeters that would make American counterattacks prohibitively expensive. All three assumptions proved catastrophically wrong. The assumption about time failed first. The attack on Pearl Harbor, intended to cripple American naval power and buy time for Japanese expansion, instead unified American public opinion and eliminated any possibility of a negotiated settlement. Remember, Pearl Harbor became a rallying cry that sustained American willpower through years of costly fighting. The assumption about American morale failed alongside it. Far from being soft and unwilling to sacrifice, American society mobilized for total war with a determination that matched or exceeded Japan's own. Rationing, war bond drives, and the conversion of civilian industry to military production proceeded with remarkable speed and public support. But it was the third assumption about the time required for industrial mobilization that would prove most consequential. Japanese planners had estimated that American industry would need 18 to 24 months to convert to full war production. They were wrong by a factor of 3 or more. American automotive manufacturers began converting to military production within weeks of Pearl Harbor. Ford's Willow Run plant, designed to mass-produce B-24 bombers using assembly line techniques adapted from automobile manufacturing, broke ground in April of 1941, months before the United States even entered the war, and was producing bombers by September of 1942. By 1944, Willow Run was completing one B-24 every 63 minutes. The Jeep itself exemplified this rapid mobilization. From the Army's initial specification in July of 1940 to the first production vehicles took less than a year. By the end of 1941, American factories were producing 500 Jeeps per week. By 1943, production had increased to 3,000 per week. By the war's end, American industry had produced over 600,000 Jeeps, more motor vehicles than Japan produced of all types combined. This production miracle was possible because of exactly the manufacturing philosophy that Yamamoto had observed in the Go Devil engine. Standardization, interchangeable parts, precision machinery that reduced dependence on skilled labor. These principles, developed over decades in the American automotive industry, allowed factories to scale up production at speeds that Japanese planners had believed impossible. And the Jeep was merely one item in an avalanche of American production. The numbers were staggering, almost incomprehensible. During the war, American industry produced over 300,000 aircraft, compared to Japan's 66,000. American shipyards launched over 5,500 vessels, everything from Liberty ships to aircraft carriers, while Japanese shipyards launched fewer than 2,000. American factories produced 88,000 tanks. Japan produced fewer than 5,000. But raw numbers told only part of the story. The quality and reliability of American production mattered as much as the quantity. This was what Yamamoto had discovered with his disassembled engine. Not just that America produced more, but that what it produced was manufactured to standards of precision and consistency that Japanese industry could not match. Consider the problem of spare parts. Every military vehicle requires regular maintenance and eventual repair. Engines wear out, transmissions fail, tires go flat. An army's effectiveness depends not just on how many vehicles it can put in the field, but on how many it can keep running. The American system of interchangeable parts meant that a Jeep disabled in the Philippines could be repaired with components manufactured in Michigan, shipped across the Pacific, and installed by a mechanic who had never seen that particular vehicle before. No hand-fitting, no adjustment. The part would fit because the system demanded that every part fit. The Japanese system could not match this. A Japanese truck disabled in Burma might require components that had been hand-fitted to that specific vehicle at the factory. If those exact components were not available, and they often were not, a skilled mechanic would have to modify standard parts to fit. This took time, demanded expertise, and often resulted in repairs that were less reliable than the original components. The cumulative effect was that American vehicles spent more time in operation and less time in repair. A single American Jeep with reliable components and standardized parts might accomplish as much useful work as 2 or 3 Japanese vehicles that required constant maintenance. American forces thus gained an effective multiplier on top of their already overwhelming numerical superiority. This disparity extended beyond vehicles to virtually every category of military equipment. American firearms were manufactured to tolerances that allowed any soldier to field strip any weapon and replace parts without adjustment. American aircraft engines were designed for reliability and ease of maintenance, accepting slightly lower performance in exchange for dramatically longer service intervals. American radios, medical equipment, and even rations reflected the same philosophy: standardized, reliable, and produced in overwhelming quantities. And Japanese forces encountered this material superiority wherever they fought. The testimonies that survived the war tell the story in human terms. A Japanese officer on Guadalcanal described watching American forces unload supplies on the beach. They had so much of everything: trucks, fuel, ammunition, food, mountains of canned goods stacked in the open. We had been eating roots and snails. We had been carrying ammunition on our backs through the jungle because we had no vehicles. And they had mountains of supplies that they did not even bother to guard. A Japanese pilot who survived the Marianas Turkey shoot in June of 1944, the aerial battle in which American forces shot down over 300 Japanese aircraft, while losing fewer than 30 of their own, attributed the disaster not to American pilot skill, but to American aircraft reliability. Our planes were fragile, he recalled. Engines failed. Guns jammed. We had to fight with what we had, and what we had was falling apart. The Americans flew machines that worked. A Japanese soldier captured on Okinawa in 1945 was interrogated about his unit's logistical situation. His response was brief. We had bullets. We had rice. Sometimes, we had nothing else. This material disparity was not merely demoralizing, it was lethal. Japanese forces throughout the Pacific died in far greater numbers from disease, starvation, and exposure than from American weapons. The Japanese military's inability to supply its troops, an inability that stemmed directly from insufficient shipping, insufficient vehicles, and insufficient maintenance capacity, transformed military campaigns into humanitarian catastrophes. Of the approximately 2 million Japanese military deaths during the war, an estimated 60% were caused by starvation or disease, rather than combat. In New Guinea alone, over 100,000 Japanese soldiers died from starvation. In the Philippines, Japanese forces resorted to eating roots, bark, and in documented cases, the flesh of fallen soldiers. Meanwhile, American forces in the same theaters ate hot meals prepared from canned and dehydrated rations, supplemented by fresh food delivered by refrigerated ships. The Go Devil engine that Yamamoto examined in his Nagoya workshop was thus not just a mechanical artifact. It was evidence of a systemic advantage that affected every aspect of the war, from the battlefield to the hospital, from the supply dump to the machine shop. It represented a way of organizing industrial production that Japan had not developed and could not replicate in time to affect the war's outcome. And Yamamoto, with his 17 years of experience and his mechanic's eye for detail, understood exactly what he was seeing. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The months that followed Yamamoto's examination of the captured engine brought the war increasingly close to the Japanese home islands. American B-29 bombers, flying from bases in the Marianas, began systematic raids on Japanese cities in November of 1944. By March of 1945, these raids had evolved into mass incendiary attacks that would ultimately kill more Japanese civilians than the atomic bombs. Yamamoto's testing facility in Nagoya was not directly targeted in the early raids. It was a small operation, not significant enough to appear on American target lists. But Nagoya itself was a major industrial center, home to Mitsubishi aircraft plants that were priority targets. Yamamoto watched the night skies brighten with flames as nearby factories burned. The air raids compounded the problems that Japanese industry already faced. Skilled workers were killed, dispersed, supply chains were disrupted, machine tools were destroyed or damaged. The already inadequate Japanese manufacturing system began to collapse under the combined pressure of American bombing and American submarine warfare that had cut off imports of critical materials. By mid-1945, Japanese military vehicle production had fallen to a fraction of its 1943 peak. Factories that had produced engines and transmissions were producing nothing, or had been dispersed into small workshops where precision manufacturing was impossible. The standardization problems that Yamamoto had observed, the hand-fitting, the inconsistent quality became worse as experienced workers were lost and materials grew scarcer. Yamamoto spent these months doing what he had always done, keeping vehicles running through skill and improvisation. But the task grew increasingly impossible. Parts that had once been merely difficult to obtain became unavailable at any price. Vehicles that should have been repaired were cannibalized for components to keep other vehicles running. The careful craftsmanship that Japanese manufacturing had prized became irrelevant when there were no materials to craft with and no machines to craft on. In late July of 1945, Yamamoto was transferred from Nagoya to a maintenance depot outside Tokyo. The depot's primary function was to prepare vehicles for the expected American invasion of the home islands, an invasion that Japanese military planners anticipated would come in the autumn or winter. The vehicles at this depot told the story of the Japanese industry's collapse more clearly than any statistics. Trucks with mismatched tires, engines rebuilt multiple times with increasingly unsuitable components, transmissions that ground and whined from worn gears that could not be replaced. Yamamoto and his fellow mechanics worked 18-hour days trying to make these machines functional, knowing that they were preparing equipment for a battle that would almost certainly end in death for the soldiers who used it. August 6th brought the atomic bomb to Hiroshima. August 9th brought the second bomb to Nagasaki. August 15th brought the Emperor's surrender broadcast. Yamamoto was in the maintenance depot when he heard the broadcast. The Emperor's voice, thin and formal through the radio static, spoke of enduring the unendurable and suffering what is insufferable. He did not use the word surrender. He did not need to. Yamamoto's reaction to the surrender was complex. There was relief, certainly relief that the invasion would not come, that the final battle would not be fought. There was grief for comrades who had died and for the Japan that had been destroyed. There was uncertainty about what would come next, under American occupation. But there was also, beneath these emotions, something like recognition. The war had ended as he had known it must end, from the moment he had examined that American engine 5 months earlier. Japan had been fighting factories, and factories had won. The American occupation that followed would bring Yamamoto face to face with the industrial system he had glimpsed through the Go Devil engine. The occupation transformed Japan with a speed that echoed America's wartime mobilization. Within months of the surrender, American military engineers had repaired bombed infrastructure, restored electrical systems, and begun converting Japanese industrial facilities to peacetime production. The efficiency was remarkable, and remarkably different from what Yamamoto had experienced in the Japanese military system. He observed these occupation forces with the same mechanic's attention he had applied to the captured engine. American vehicles filled the streets of Tokyo jeeps, of course, but also 2.5-ton trucks, staff cars, and specialized equipment of all kinds. All of it appeared to be in excellent condition. All of it appeared to work. Yamamoto found employment in late 1945 with a small automotive repair shop in Tokyo that served both Japanese civilians and occupation personnel. It was through this work that he gained direct experience with American maintenance practices that confirmed and extended what he had deduced from the disassembled engine. The first revelation was the parts supply. American military units maintained inventories of standard components that could be requisitioned through a systematic logistics network. If a Jeep needed a new water pump, the water pump could be obtained usually within days, sometimes within hours. The part would arrive in packaging that identified its specifications, and it would fit without adjustment. Yamamoto had never experienced anything like this. In the Japanese military, obtaining parts had required personal relationships, informal networks, and endless improvisation. A needed component might exist somewhere in the supply system, but finding it and obtaining it required knowledge and connections that took years to develop. The American system replaced this personal knowledge with standardized procedures that any clerk could follow. The second revelation was the technical documentation. American vehicles came with maintenance manuals that specified every procedure in detail, not just what to do, but exactly how to do it, with illustrations, torque specifications, and step-by-step instructions. These manuals assumed that the mechanic might have limited experience. They were designed to transfer knowledge efficiently from page to practice. Japanese technical documentation has been far less comprehensive. It assumed that the reader already possessed substantial expertise that could only be gained through years of apprenticeship and experience. This approach conserved paper, but limited the number of people who could effectively maintain equipment. The third revelation was the inspection system. American maintenance procedures included systematic inspections at specified intervals. Check these components at 100 miles, these at 500, these at 1,000. Potential problems were identified and corrected before they caused failures. The goal was not to fix breakdowns, but to prevent them. Japanese maintenance had been more reactive. Vehicles were repaired when they broke. The concept of preventive maintenance existed, but the parts and time required to implement it systematically were rarely available. Japanese mechanics were skilled at emergency repairs. American mechanics were skilled at making emergency repairs unnecessary. Yamamoto incorporated these practices into his work at the repair shop, and he found that they transformed his effectiveness. He could maintain more vehicles in less time with fewer failures. The skills he had developed over 17 years remained valuable, diagnosing problems, understanding mechanical systems, but the American practices multiplied what those skills could accomplish. He began to understand that he had been observing not just different machines, but a different relationship between human skill and industrial systems. Japanese manufacturing had tried to build quality into products through skilled workers. American manufacturing had tried to build quality into systems that would produce consistent results regardless of individual worker skill. Both approaches had merit, but only one could scale to the demands of global war. The occupation authorities, as part of their effort to rebuild Japan's economy, brought American industrial consultants to teach modern manufacturing techniques to Japanese industry. These consultants introduced concepts that would eventually transform Japanese manufacturing: statistical quality control, systematic process improvement, standardization of components and procedures. Yamamoto did not work directly with these consultants. He was a mechanic, not a factory manager, but he followed reports of their activities with keen interest. He recognized in their teachings the principles he had deduced from the Go Devil engine: quality through precision machinery rather than individual craftsmanship, consistency through standardized processes, reliability through systematic inspection and maintenance. These principles would ultimately be adopted and adapted by Japanese industry with remarkable success. The Japanese manufacturing system that emerged in the 1950s and 60s would combine American techniques of mass production with Japanese traditions of continuous improvement and worker engagement. The results would challenge and eventually surpass American manufacturers in many industries, including the automotive industry that had produced the Jeep. But this transformation lay in the future. In the immediate post-war years, Yamamoto simply worked, maintained vehicles, and thought about what he had learned. He thought about the engine on the workbench in Nagoya. He thought about the bearings that had barely worn after 10,000 miles. He thought about the standardized parts and the precision machining and the maintenance manual that told mechanics exactly what to do. And he thought about what might have been different if Japan's leaders had understood these things before they started the war. The decision to attack Pearl Harbor had been based on a fundamental misunderstanding of American industrial power. Japanese planners had known the statistics: American production capacity, American resources, but they had not grasped what those statistics meant in practice. They had believed that Japanese spirit and skill could compensate for material inferiority. They had believed that the war would be decided by willpower rather than production lines. 10,000 miles without an overhaul. That number contained a lesson that Japanese planners had not learned until it was too late. That industrial systems could achieve results that individual skill and determination could not match. The American mechanic who maintained that Jeep had probably not been as experienced as Yamamoto. But the American mechanic had worked within a system of precision manufacturing, standardized parts, and systematic maintenance that multiplied his effectiveness beyond what any individual skill could achieve. The war had been decided not on the battlefield but in the factory, not by which soldiers were braver but by which systems were better. Yamamoto remained in Tokyo through the 1950s, working in automotive maintenance as Japan's economy recovered and then began to grow. He saw Japanese industry adopt the techniques that American consultants had taught and then improve upon them. He saw Japanese vehicles grow more reliable, more precisely manufactured, more systematically maintained. In 1963, he purchased a Japanese automobile, a small sedan produced by one of the companies that had manufactured military equipment during the war. He maintained it himself, carefully, using the systematic procedures he had learned from American practices. The engine ran for over 80,000 miles without a major overhaul. He thought, sometimes, about writing down what he had learned from the captured Jeep engine. The story seemed important, a small window into a large truth about why the war had ended as it did. But he was a mechanic, not a writer, and the story remained untold. Yamamoto died in 1987, at the age of 79. By then, Japanese automobiles had become famous worldwide for exactly the quality he had first observed in the American engine: precision manufacturing, reliable components, systematic maintenance procedures. The student had learned from the teacher and then surpassed him. The Jeep itself remained in production, in various forms, for decades after the war. The basic design, simple, rugged, standardized, proved adaptable to civilian use, and the vehicle became an icon of American culture. The Go Devil engine was eventually replaced by more modern power plants, but its philosophy of reliable simplicity influenced automotive design for generations. In the end, the story of Yamamoto and the captured engine is a story about systems. It is easy to focus on individual machines, individual soldiers, individual battles. But the Second World War was won by systems, manufacturing systems, logistics systems, maintenance systems that multiplied individual efforts into overwhelming collective capability. The American Jeep was not a sophisticated machine. Its engine was not powerful or innovative or elegant. But it was produced by a system that could manufacture 600,000 copies, each one identical to the others, each one reliable enough to run 10,000 miles without major repair. That system, more than any weapon or strategy, determined the war's outcome. Yamamoto understood this, standing in his workshop in Nagoya in March of 1945, looking at bearings that showed barely any wear after 10,000 miles of operation. He understood that he was seeing not just an engine but a civilization organized around principles of standardization and mass production that Japan had not yet learned. The lesson would not be wasted. Japanese industry would learn those principles, adapt them, and build upon them. The manufacturing techniques that had defeated Japan in 1945 would make Japan an industrial superpower by 1975. But in March of 1945, that future was invisible. There was only the engine on the workbench, the report that would change nothing, and the knowledge that the war was already lost. 10,000 miles without an overhaul. Sometimes the most profound truths are mechanical. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.